So saying that here, right? It's the
Yes.
questions are connected. It's not just one question, no. They are connected. So we're looking at it from this point of view. This is the original loan amount. Original amount for the loan was 12,053.56, right?
Mm.
So we're trying to build a loan amortization schedule so we can find what year it is in. So I'm now saying, using the same principles of loan amortization, right? Just zoom in here. So I'll join the schedule here. Okay. So here we're going to have, in the first column, we have our year, the years here. We're trying to figure out how many years are there. So you have the year here, the year, Y will be here. Then you're going to have opening balance, OB, opening balance. You're also going to have our interest now, I. Our interest rate, our interest figure, not the rate, the figure itself. Then the installments. Then thereafter, we're going to have the capital repaid, cap repaid. And then lastly, we're going to have the closing balance, CB. So the years are as follows. Year 1, 2, 3, 4, 5, 6. What's opening balance? 12,000. 83.56, right? Remember the first time? Remember that? Do you recall this part?
Yes, we do.
Yes.
Okay, so we're now saying we find 5% of this. 5% of 12,033.56. So times 5.0.05 will give us 601. So interest at 5%. 5% here. 601.68 here. The installments are 1,000 throughout. From the question, we have equal installments 1,000 throughout. So therefore, the capital repaid will now be the installment minus the interest now. So 1,000 minus the 601.68. 1,000 minus 601.68, which will give us 398, sorry, 0.32 here. And therefore, our closing balance will now be the 12. So closing balance, we go back here, is the opening balance minus capital repaid. So 12,033.56 minus the 398.32, which will give us 11,635.24 here as the closing balance. That becomes our new opening balance here, 11,635.24. Then 5% of that will give us 581.56. The 1,000 minus that.
Just hold
Yes,
on.
sir. Yes, sir.
The closing balance, I think let's try to recalculate it.
Yeah, okay. So I said closing balance here, I was saying is opening balance minus capital repaid. This opening balance minus this here, capital repaid. That's gives us closing
I
balance.
think the total is wrong.
Okay, let me try. So 12,033.56
It's okay.
It's okay.
minus 398 minus 398.32 It's actually correct.
Oh, okay.
Yes, yes. So 5% of this will give us this here. Installments are the same again, they're still constants here. This here will now give us, so say 11,635.24 times 0.05. 276 here, 1,000 minus this will give us 418.24 here. And saying 11,635.24 minus 418.24 will give us 11,217 here for year 2. So I'm trying to find the point at which this particular closing balance will match up to the 8,790. So until we get to that point, let's find the year. That's one time I'm going to find the year at that point. That's how we determine X now at that point. Okay, so that becomes our new opening balance now. 11,217 times 5%. So our interest here becomes 560.85 and 1,000 here. Principal installment, the same installment. That's 50.85 to give us 489.15. So I'll say 11,217 minus answer plus 10,777.85 here, which becomes our new imbalance in year 4, 10,777.85 times 5% now will give us 538.89 and 1,000 minus that. We're going to get 1,000 here, 461.11. And now 10,777.85 minus capital repaid. We're getting 10,31.6.74 here. So now keep moving the same way. This becomes an opening balance, 10,31.6.74. So 10,316.74 times 0.05. We're getting 515.84. So observe how I'm getting closer to the interest of this one, 430 something. So when you get to that point, means I'm actually almost there. So as we keep on going, as the years keep on moving, the interest figure keeps on changing. So now I'm saying that 1,000 minus that will give us this side 484.16, then 10,316.74 minus give us 9,832.58 here. That becomes the 1 year 6 now. 9,832.58 times 5%. times 5% to give us 491.63. Hope I'm following through. 1,000 this side. 1,000 minus 491.63 will give us 508.37 and 9832.58 minus capital paid is going to be 932 4.21. Year 7 here, 932 4.21 times 5%. Give us 466. 466.21 and 1,000 minus that answer. Getting 1,000 here. Here's 1,000 throughout. 1,000 throughout here. And we have 583.79. Now, 932, 9,324.21 minus 533.79. What are we getting? 8. We're getting 8,790.42. And this resonates what's in the question. It's just close to some because of what's the thing? Because of rounding off differences, but it gives us 8,790.4 as that we need there. Are we okay? The only reason why it's like this is because of changes in interest. So which means that for it to be like this here, means in year 8, we're going to have that here, 8790.42, given as our principal amount here. So which means the value of X here is what? 8. Are we okay? Are we following?
Yes. So now suppose we say we pick 7 because that's where it ended as at December. Are we going to be wrong?
No, not really. But then look at it. It says outstanding balance at the beginning of the year is this, right? Outstanding at the beginning of the year.
Yes. At the beginning of the year. Okay.
Yes.
Okay. So now, is there any other way of finding this year without using this table? Or it be difficult?
Sadly, there is no other way because the only other way is using the computational basis, using computers, but that's a different scenario.
In fact, this is the simplest way.
This is the simplest and safest way because everything else just aligns. Yes, are we okay so far?
Okay, following. It's clear.
Right. So let's look at the next question. All right. Thank you. See, okay. Let's look at question 3 now. It says at the beginning of year 11, it is agreed that the interest rate will not take place. The increase in interest rate will not take place. So the rate means at 5% per annum for the remainder of the loan. The annual installment will continue to be paid by the same level, so that there may be reduced term and reduced final installment. Calculate by how many years, if any, the payment schedule is shortened. So here, this entire question dealt entirely on this. So remember, the present value of this initially was the present value of this one initially was the 12,000. The initial amount for the investment was 12,000 at 33.56. So what are we trying to look at here in this case? If it remains 5% after year 20, the rate won't change at that point. Because now if the interest rate is changing, it's going to lead to a shorter term and a final reduced installment. So trying to figure out how many years loan is shorted. So all we do is find the present value of the actual annuity factor. So our annuity factor here, we're saying the present value of the annuity here, use reading here, of the annuity. So our initial amount was 12,300.56 here. So now, just dividing this over 1,000, the equal payments here, over 1,000, will give us our annuity factor. Our annuity factor this side. Because remember, the present value of annuity factor is PV is equal to A times present value interest factor over the annuity. This is that formula we had here, this thing, this part here is the PVIFA. So now we're trying to find this here, what's in the brackets in time. So we just say 12,000 over 1,000 to give us 12.0356, which is round of 12.034 here. We don't have that part here. So now, if that's the interest factor for the annuity here, right? What do we do now at this point? What do we do?
So
Okay,
maybe
just a moment.
I don't know why I didn't understand the question. So maybe just try to clarify what you are trying to look for, because the question is on the soft copy, so I'm not able to say it clearly.
So what we're trying to look for here in this case is we're trying to look for the term, the loan is shortened. The loan is shortened. So naturally, I won't explain this to you. Naturally, in the exam, they won't actually compute this one. The reason being because you cannot actually find the term is shortened using manual methods. Are we clear? Are we all clear so far? Here. We cannot find this using manual methods. It's nearly impossible. It's either using Excel tables or a financial calculator. That's how you find such questions. So because of that, you don't actually find and solve it here. Are we clear? Are we all clear? Hello?
So are we still looking at the same question where we had 12,000? Even this one is it's the same question, right?
It's the same question, yes. Same question, yes. But because of that, part 3 can actually be solved using manual methods for part 3. It's nearly impossible to solve part 3. It's a financial calculator for this one. Yeah, part 3. You can actually solve using manual methods. Manual is impossible to solve. I won't even lie to you. Manual is nearly impossible to solve. Are we okay?
No, okay.
Yes. So because of that, because you're trying to now look at the basic formulas and manual calculations, which would take up a lot of time in the exam. Already, we found the annuity factor interest, right? We found the value there. Okay, let's try solving it. Can we try solving it? Can we try?
Yes. Show us how we can solve it in an exam, yes.
Okay. So let's
the easiest way,
right? So I'm saying present value of an annuity is equal to the annual payments multiplied by 1 minus 1 plus R to the power negative n over R, right? Over R, right? Now our R in this case is 5%. So I'm saying the initial amount was 12,033.56. We can try solving manually. It equals 1,000 plus 1,000 here times 1 minus 1.05 was 5%. The power negative n. N is unknown. We're looking for n here. Over 0.05. So now, this side will say 12,033.56 over 1,000 is equal to this side here, which is 1 minus 1.05 the power n over 0.05. This side is giving us, of course, we got this as 12.0336 6 is equal to 1 minus 1.05 the power n over 0.05. So at this point, let's cross multiply here, right? So I'm saying 5% of this. So I'm saying 12.0336 times 0.05. This side will give us 0.60168 is equal to 1 minus 1.05 the power n. The negative goes as the second comes side, the switch sides. So 1.05 the power n is equal to 1 minus 0.6168. 1.05 the power n be equal to 0.39832. We then find the natural logarithm of this one, natural logarithm of these functions that are here. Natural logarithm of these functions that are here. So I'll say n in this case, n will be equal to natural logarithm of 0.39832 over natural logarithm of 1.05. 1.05. Are we okay there? To give us natural logarithm of 0.39832 divided by natural logarithm of 1.05.
I think I'm behind.
Where, at what point?
Okay. The point where we put 12,033.56 divided by 1,000.
Yes, here, this point.
Yes,
Here.
so up to there, I'm clear. Now from there going onwards,
Okay, so
I haven't understood the thing.
Okay, so when we divide this part here, right? When we divide this part, this remains 12.036 on this side. Now we're left with this other side
Yes.
here, but then there's a fraction here. The fraction covers everything, so we just cross multiply to get rid of the fraction, to get rid of the fraction. So now when you cross multiply,
So you're saying you cross multiply?
Yes, so it's going to be 12.0336 times 0.05 will be equal to 1 minus 1.05 the power n here. Are we okay so far?
Okay, so in short, there where we've reached, we're trying to get rid of the 0.05
Exactly,
as
yes.
a denominator on the 1 minus 0.05 to the power n.
Yes, yes, we are.
Okay.
Okay, so now this will give us 0.60168 here. This and this part here. So this moves on, gives us this here. Are we okay? Are we good to go?
I'm just copying that because as of now I'm not using the calculator, but at least I understood when you explained.
All right, all right.
Okay, we can continue.
All right. Excellent. Okay, proceed. Now here, when you do all that, natural logarithm should give you a negative, but then you don't pick the negative value. You don't pick the negative value, you pick the absolute value. The absolute value is what you pick. Pick the absolute value of this. So which means that you're going to get, the reason why it's negative is because was the power negative here. Was the power negative throughout here. Was the power negative. Was the power negative n here throughout. So pick the absolute value, you're going to give us 18.87. So n is 18.87 years here. That's n. So if that's n, it means that the loan is shortened by how many years? 20. Because loan term is 20 years. So 20 minus 18.87, which will give you which will give you 1.13 as the shortening period. So loan is shortened by 1 year and some months, 1.13 years. That's how long the loan is shortened for. So like I mentioned before, it's easier using calculators, using financial and Excel tables, but then manually it's a bit more challenging than usual. Yes, are we okay? Are we okay now? Are we okay now?
Yes. So did you say there are two methods? So this is the second method that you showed us, that you are showing us?
This is the manual method, the manual one, the manual method.
This is a manual one.
Yes. This is the manual one, the one that you use now solving manually. Are we okay so far?
So I don't just know I'm getting loan logarithm. So when you are placing the calculator, is it not to place on the log, then you put that number 0.3982, you divide log again 1.05.
First press log, then now you get that number, then press answer. So press log.
Oh.
Yes.
Log, then you put that 0.398. 39832. Then you press answer.
Yes.
Oh, okay, then again I divide.
Over, divide then log 1.05.
Log. Okay. Oh, okay, I get it now.
Yes. Are we okay so far? Okay, so now this covers part A of the question now. Part A of the question has been covered successfully. Now with that in mind, we find part B, right? Part B says, what is the reduced final installment now? So remember, you're paying 1,000 for 18 years, right? 1,000 for 18 years. So in the last year, it's a bit different than last year. Last year is a bit different. We need to find the present value of the 18 installments first. The 18 installments first. Okay. Okay. We'll look at this one in our next session in the next 20 minutes at 12:30. Is that okay? We'll start from here and go to question 6. Is that fine?
Okay, that's fine. So in the next 20 minutes, so meaning we need
Yes,
to log in at
12:30.
12:30. Okay.
Yes.
Okay.
All right. Okay. Thank you.